Okay, so we've had some questions where they messed with us by not telling us the genotypes of parents, and we had to figure them out from phenotypes or from a little bit of guess and check. Now, we sink to a new low where we don't even get to our legend before we run into trouble, because they say among cattle there's a trait called polled, and polled means you don't grow horns. Most cattle do, some cattle don't. And they tell us some things about the offspring, but we can't even get our legend set up because they don't tell us if the polled trait is dominant or recessive. So, how do we deal with this? They tell us that the parents for several offspring are the same two polled cattle. So here's a dad that we know nothing about, and here's a mom that we know nothing about. And for phenotype, we'll say they're both polled. And from there, they have 5 calves, of which some are polled and some aren't. Some are horned. And they say, is this a dominant or recessive inheritance? In other words, figure out what the legend should look like just based on what happened here. Well, good news, there are only 2 possibilities. One of them is polled as dominant, meaning it would be big P is polled and little p is horned. Or the other possibility is, I'll go different letters for this one. We'll say big H is horned and little h is polled, as in no horns. What do you think? Any any hunches as to which one of those would work and which one would not? I'm going to try them both, so it's okay if you're unsure, but or if you need some time to think, hit pause and come on back when you're done. We'll try them both out. Okay, so let's try this. Let's say that horned is normal. Most cattle have horns, so let's say that horned is a dominant. Here's what that would mean if we filled in all these blanks. Assuming this polled bull would be little h, and this polled cow would be little h. Now, what does that mean about the offspring? Dad can only contribute little h's. Mom can only contribute little h's. That would mean every single one of their offspring would have to be little h, and horned cattle would be impossible. Right? If you're double recessive, you don't have any dominant alleles to give, and if your cattle spouse doesn't either, then that means there's no dominant alleles in this whole family. They'd have to be just 100% polled all the time. So this actually is impossible. There's no way this can explain the fact that there are horned offspring. So let's just scratch that out. That seems like it wouldn't work. We'll clear that out of there. Let's see if this worked. If polled is dominant, then that would mean this parent is, now we have a new problem. If this parent is polled, then that would mean, let me finish my legend here. Big P would be polled. Big P, little p would be another version of polled. They both have a dominant allele. And little p would be horned. So if you have polled cattle like this, you know they're big P and don't know. And it's the same for the other parent. They're big P and don't know that either. So can this work? Can we fill in these blanks? Down here we get polled offspring who have a capital P. We don't know what their second allele is either. But this is possible at least because both parents have a big P they could have passed on. Is this interesting? This really is. If you have horned offspring, that means they're little p. That's the only way you can have horns. And this is great news because if these offspring are little p, what does this mean? One of these came from dad, the other one came from mom, which means both of these have to be little p's. The only way you can have recessive offspring is if each parent contributes one of those recessive alleles. That's exactly what happened here. So now we know exactly what's up with both of our parents. For these polled offspring, we're probably never going to know. These could be big P, that could happen, or they could be big P, little p, but either way they'd end up being polled cattle. Until these grow up and start being parents themselves, it'll be hard to figure out exactly what their genotype is, but we can tell this for sure. So the question is this an example of dominant or recessive inheritance? We could say here, when we assumed that horned was the dominant trait, nothing made any sense and we couldn't make this family tree work. When we assumed that polled was the dominant trait, then everything worked out fine. So we believe that the polled trait is a dominant one, or the polled allele is dominant, and the horned allele is recessive. So again, a question where we didn't exactly use Punnett square techniques, but we used a lot of the concepts of dominance and inheritance and segregation, where you only get to pass on one of your alleles. All of that stuff can help us figure out genetics problems.